Hello, this is Mr. P with the Chapter 8A practice test. This is problem number 12, where they ask us to prove the statement using an induction proof. For this statement, we're saying that 6 plus 12 plus 18 all the way up to 6 times the number is going to be equal to the expression 3n times the quantity n plus 1. Well, for an induction proof, our first step should always be to show that the formula is valid when in the first case, when n equals 1. So to do this, we're going to use n equals 1 on the left side and the right side. On the left side, that just means we want the first term only, which is 6. And on the right side, we're going to replace n with 1 wherever we see n. When we do that, we get 6 equals 3 times 1 times the quantity 1 plus 1. Which when you do the arithmetic is 6 equals 6. So therefore, yes, the formula is valid when n equals 1. The second step, or the second part of the proof, is to show that we're first going to assume that this is true for some specific case, and then show that that leads to it also being true for the next case. In other words, we're going to assume that S sub k is true. We're going to show that this formula is true for some specific integer value of k. N was the general term. K means a specific integer. And using this as a true statement, we can then write the k plus 1 statement by simply replacing k with k plus 1. That means on the left side, we have all the terms we had before, plus one more term. That would be the k plus 1 term. And on the right side, wherever we have k, we replace it with k plus 1. So this k becomes this parenthesis, and this k becomes k plus 1, which is k plus 2. So in both cases, we're replacing k with k plus 1. And now we need to show that the left side does equal the right side. Like other proofs, we're going to work on only one side at a time. So working on only the left side, I'm first going to make the substitution that this part of the series from 6 to 6k, we already said that it's equal to this expression. So I'm going to make that substitution. Instead of this part from 6 to 6k, I'm going to replace all of that with 3k times k plus 1. And then we still have the additional term. And now, again, algebraically, I want to make this look like this. So if you look at your goal and notice that you have all, it's a product, you have all multiplication, then that should be a red flag that you're probably going to do some factoring. Here we have k plus 1 is common to both terms. So if we factor out the common parenthesis, what's left is 3k and 6. And we're almost where we need to be. We simply notice that 3 is common to both of these terms, so we factor out the 3, and that gives us 3 times k plus 1 times k plus 2, which is exactly what we were looking for on the right side, so therefore it does check out. So if we assume that some integer k is true, then we can show that the next integer would also be true. So both of these put together means we can say, therefore, the formula is valid for all positive integer values of n. And we're done.